Hey everyone. Okay, so chapter 13, as you remember, is based on annuities due. So payments being made at the beginning of each period. So this first question, what it covers is comparing the two. Okay, so annual contributions of 1,000 will be made to a tax-free savings account for 25 years. The contributor expects investments within the plan to earn 7% compounded annually. What will the TFSA, tax-free savings account, be worth after the 25 years if the contributions are made at the end of each year or at the beginning of each year? Okay, so for 25 years at the end of each year, so let's have a look. We know that 7 is the IY. We know that it's annual, so we want to change the payments per year and the compounding per year to be 1. We have an N of 25 years. Present value is 0. And then 1,000 at the end of each year for the A. So 1,000 is going out of our pocket, so we have to change it to minus 1,000. So 1,000 plus minus button payment, and then compute future value. So this is telling us that under these circumstances, we will have $63,249.04. But what happens if we make it at the beginning of the year? So instead of waiting a year to make a payment, we make that payment right now. Let's have a look. Okay. So if we want to put it in the beginning mode, okay, so you want to change it to the beginning mode, and you want to re-enter all of the year information. And then we have, because everything else stays the same, the only thing that changes is the beginning mode. So then CPT future value is going to give us $67,676.47. Okay, so you can see right there just by looking at it that you're getting over $4,000 more. So let's have a look. Let's compare the two. So for the percentage difference, you've got your 67,676.47 minus off your 63,249.04. Okay, so you get the difference between the two, which is a little over 4,000. Divide it by the 63,249.04. Multiply that by your 100, and then that's going to give you your percentage increase. And it works out that you get 7% more by putting it in at the beginning of the term. All right, so let's have a look at number 5. Okay, so Tanisha plans on investing $10,000 at the beginning of each year for the next 14 years. If her invested funds earn 5.1% compounded annually, what will be the total accumulated value of her investment after 14 years? So again, you want to put it into the beginning mode. Then we want to put 5.1 IY. Then we want our payments per year and our compounding per year to match at 1 because it's done annually. We have 14 years, so 14N because it's only annually, so it's 14 times your 1. Present value is 0. We have 10,000 plus minus button and then payment, and then compute your future value. And your answer works out to $207,416.86. And this is based on it being in the beginning mode and that a payment is done immediately. Okay, so let's look at 9. Salvatore will contribute $500 to a mutual fund at the beginning of each calendar quarter. Okay, so again, it's beginning mode and it's quarterly, so 4 times a year. A, what will be the value of his mutual fund after 6.5 years if the fund earns 7.6% compounded annually? Okay, so the payments are being made quarterly. but the compounding is happening annually. So we can see right there our PY and our CY are different. So we have to remember to put those in. So let's do this part first. Okay, so we want to make sure it's in beginning mode. We have 7.6% IY. We want our payments per year to be 4, our compounding per year to be 1. We have 26 for our N, which is quarterly, times your 6.5 years. 0 present value. Your payments are 500 plus minus to put it to negative 500 payment. Compute future value, and your answer works out to $16,803.44. How much of this amount represents investment earnings? Okay, so let's have a look at that. So the way we can figure this out is we know what the total amount was at the end. It's $16,803.44, and we know that Salvatore contributed 526 times. Okay, so if you calculate that, your 16,803.44 minus your 13,000, which is your 26 times 500, that means that the amount of interest that was earned over the life was $3,803.44. Moving on to 13.2, we have 3 more problems to go over. Okay. So an annuity consists of quarterly payments of $9.50 for 8 years and 9 months. So 8.75. Okay, 8.75 years. Discounted at 4%, so there's your interest, compounded quarterly. Determine the present value of the annuity if the payments are made at the end of each quarter, at the beginning of each quarter, and then again, just like we did in chapter 12, in 13.1, by what percentage does the answer in part B exceed the answer in part A? So coming up with our percentage. So at the end of the quarter, we have 4 is your interest rate. Okay, so 4 IY. We have our payments per year, again, of 4, and the compounding per year is 4, so we want to put the 4. We have 35 for our N, right? You've got 8 years, 9 months, which is 8.75. Multiply that by your 4 to give 35 for your N. We have a payment of $9.50, 0 future value, compute present value, means that the present value that we must contribute is $27,938.15. And that, of course, will be the negative because we are contributing that. It's coming out of our pocket and going into savings. Now, what happens if it's at the beginning of each quarter? So everything is going to be the same. The only thing we need to do is change it to beginning mode and then recompute the present value, and that's going to give us an answer of $28,217.53. So again, we want to subtract the $27,938.15 from the $28,217.53. Divide that by your $27,938.15. That's going to give you a decimal. We want to multiply it by 100 to give our percentage, and it's giving us a 1% increase by us doing it at the beginning. Question 3. What is the present value of an annuity due consisting of semi-annual payments of $1,000 for 25 years if money can earn 4% compounded semi-annual and 8% compounded semi-annual? Okay, So they're both semi-annual, so our PY and our CY are the same. We have 4 for our IY. We have 50 for our N, which is 25 times 2. Our payment is 1,000. Our future value is 0. Compute present value gives us an answer of 32,052.08. And that's if it is 4%. If it's 8%, our answer changes to 22,341.47. So therefore, the amount that we need to contribute up front is about 10,000 less than if it was at the end as opposed to the beginning mode. Okay, our final question. Question number 7 is Carmela purchased a refrigerator under a conditional sale contract that required 30 monthly payments of $60.26. With the first payment due on the purchase date. Okay. The interest rate on the outstanding balance was 18% compounded monthly. What was the purchase price of the refrigerator? Okay. So what we need to do is put all of our information in and figure out what the present value is, and that is going to represent the purchase price of the refrigerator. So again, we need to figure out if it is an ordinary or if it's a due annuity. Sorry about that. So we know that the payments are going to be made at the beginning. Okay, so that means that it is an annuity due. So we need to put our calculator into the beginning mode. Then we have an interest rate of 18. We have payments per year and compounding per year of 12. We have a 30 N. Okay, so for 30 months. We have 60.26. We need to put it as a plus or minus to turn it into a negative $60.26 because that's the payment coming out of our pocket. So it's a PMT. At the end of all this, the future value is going to be 0. So we need to compute the present value. And that works out to a purchase price for the refrigerator of $1,468.90. How much interest did Carmela pay during the entire contract? Okay, so we know that the amount was 30 payments of $60.26 per month. So multiply that out, subtract off the purchase price, so the present value amount of $1,468.90, and that tells us that over and above the $1,468.90, we paid $338.90, and that represents the amount of interest that was paid. Hope this helps. Let me know if you have any questions. Thanks, everyone.